Hey everyone! Today what we're going to be talking about is how to algebraically determine the axis of symmetry for quadratic functions. I'm going to do two different examples. Example 1. Determine the equation of the axis of symmetry for a quadratic function that goes through the points 3 and 5 and negative 10 and 5. When I'm looking at a question like this, first, just to give us a visual, I want to see kind of what this graph is going to look like. And this is going to be a very, very rough sketch. So what we have is a point at 3 and 5. So about here, and then we have a point at negative 10, like so. Quadratic functions are either going to look one of two ways. They're going to go through both these points and it's going to open up, so maybe something that looks like this, or it's going to go through those 2 points and it's going to open down. Either way, what we notice is that these graphs would be symmetrical in that they have the same axis of symmetry. So if I was to draw the axis of symmetry in, it would be like about somewhere in here. And so if I had to guess, maybe just on my rough sketch, maybe I'm thinking it's around -2, -3. Remember, I didn't really draw that to scale, so it's probably not very accurate. But what we're really trying to find is what is the middle value between the 2 points that I've been given. So how do I algebraically determine that? Well, the most important part are the x values. The x values for both points are at 3 and at -10. What I'm really trying to find is what is the middle value of 3 and -10, because that's going to help me find this line right here. So finding the middle value of any two numbers, we're just going to find the average. So we're going to add them together and then divide by 2. So what we'll get here is -7 divided by 2, and we get -3.5. So I'm going to put x is equal to, this is going to be the x value of the equation. Any vertical line can just be stated as an equation as x equals -3.5. So my axis of symmetry is this line. Let's try a few more examples. Example 2. Algebraically determine the axis of symmetry of the function f of x equals x squared minus 8x plus 12. I'm going to show you 3 different ways that you can do this. Way 1 is by factoring. If you don't know how to factor a quadratic function quite yet, I would actually try to go look up some other videos of that first, just because I am going to go through this fairly quickly. So what we're going to start with is our function. We have x squared minus 8x plus 12, and I want to factor this. So I need to find 2 numbers that multiply to 12 and add to -8. The 2 numbers that are going to work there is -6 and -2. Because I have these numbers, I can go straight to my factors since I have an a value equaling 1, and my factors will be x minus 6 and x minus 2. This is going to allow me to find the x-intercepts. So the x-intercepts of this function are going to each come from each factor. So my x-intercept, I'll have one at +6, and I'll have another one at +2. Now that I know where the x-intercepts are, and again, just giving us a visual of what this means, I have an x-intercept here at 2, 3, 4, 5, and another one at 6. So again, what I'm looking for is what is the middle value of those 2 numbers. So this is going back to our first problem. We're going to add the 2 numbers together, and we're going to divide by 2. So x equals, so we'll have 8 divided by 2, which gives us 4. So our axis of symmetry is at x equals 4. Way 2 of doing this is going to be with completing the square. Once again, if you don't know how to complete the square, or if this sounds unfamiliar to you, I would go and watch a few videos on how to complete the square first, because again, I'm going to go through this pretty quick. So once again, you're going to start with your function, f of x equals x squared minus 8x plus 12. What we need to do is turn this into vertex form. So to do so, we're going to have x squared minus 8x. What I need to add into the function is taking the middle term. I need to divide it by 2 to give me -4. And then I need to take that number and I need to square it to get +16. And this is what I need to add into my function to create a perfect square trinomial. Because I can't just add 16 into it, I also have to subtract 16, so that this is just a fancy version of adding 0, and I still have that +12 at the end. So what I'm going to do with these first 3 terms is I'm going to factor them using and then creating a perfect square trinomial. So 2 numbers that multiply to 16 and add to -8. The 2 numbers that will work there is 4. Sorry, I should say -4 and -4 and -4 and -4. I can jump right to my factors. I'll have x minus 4 because I'll have 2 of them that are going to be the same. I'll have it squared. And then I just need to put together these 2 numbers at the end, which will give me -4. And now I'll have a vertex. at 4 and negative 4. The axis of symmetry is always going to be the x value of the vertex. So once again here, I'm getting x equals 4. Last way of doing it is kind of relating back to the first problem. All I really need to do is find two numbers that have the same y value and then just find the middle of their x values. So I'm just going to find 2 points. The reason I like this way is that it avoids you having to do the full completing of the square. So we're still going to start with our function, f of x equals x squared minus 8x plus 12. And what we're going to do is, instead of going through this whole completing the square business, all I'm going to do is factor out an x from the first two terms. So I'll get x times x minus 8, and then I'm adding 12 at the end. So all I've done is factored an x out of the first two terms. What this allows me to do is kind of work with way 1, where I was just trying to find the x-intercepts. I was just taking both factors and setting them equal to 0. I can kind of do the same thing here. If x is equal to 0, in this equation, when I input 0, I'd go 0 times anything is 0, and I'd get 12. So what this means is that I have a point at 0 and 12. I could do the same thing with this factor. If x was equal to 8, well, 8 minus 8 would be 0. 0 times anything would be 0, and then you add 12. So you get a point at 8 and 12. Now we're just back at the very first problem. I'm just trying to find the middle ground between the x values. So I'm going to take the two numbers, add them together, and I'll divide by 2. So this will give me 8 divided by 2, and once again, we have 4. So there's 3 different ways of algebraically determine the axis of symmetry for the following function. I hope this helps you. Let me know if you have any questions. Bye.